going to start now. Hello everyone and a very good afternoon and welcome in for the Twister talk today. My name is Aastha Grover and I'm a software developer working with Intel and I have been working on Zephyr project for more than 3 years now. And I'm going to be talking about Zephyr and its the Twister and its test utility for the contributors. And anybody who is a developer, a user, or a contributor can benefit from this talk today and gain some insights, if not all, but few new insights. Okay, so the outline of the presentation today looks like I'm going to talk about how do we run Twister, how is it like to add test cases to Zephyr, and the various features that Twister has to offer. And also about running Twister on hardware and how does the testing on an actual target looks like. And I'll also touch on the other options which Twister has to offer and some other topics as well. And here is my GitHub handle. If you want to connect later, you can find me on GitHub with this AasthaGR handle. So now all of you might be already knowing what Twister is, but there might be some who are new to Twister. I'll familiarize them with what Twister is exactly. It's a test runner tool and it is scripted in Python. It scans the Zephyr OS codebase and it scans for the test cases and samples and tries to execute them. So we know that there are numerous pull requests which come in each day, and there are numerous pull requests coming in each day, and we need the Zephyr tree to be buildable at all times, and we need to avoid any regressions in the Zephyr tree. So and Twister does the job for us by executing all the test cases on various platforms and architectures. And it also helps developer to focus on just developing new features and make the Zephyr codebase coherent at all times. So by default, Twister would just limit its set of test cases on the boards which are marked as default in the board definition file. It would not run on all, but only the ones which are marked as default, because it takes large time to execute, so it just runs on limited tests. But it is sufficient enough to maintain the Zephyr coherency, because it cannot run on all the hardwares at one point of time, but it does sufficient testing though. And the default option builds most tests on the default set of boards and runs on the emulator if the emulated environment exists for that particular platform or architecture which you want to test. So we know that now what Twister is exactly, but how do we run it? We can invoke a full Twister run or by just invoking the Twister command from the command line. It will execute all the test cases on the default architectures and platforms, and it takes large time to execute all the set. So this is primarily done in CI. And we can also leverage Twister options and its capabilities by providing it the -t option, which is to provide the directory path of the test case, and -p option to specify the platform name. So you can invoke the Twister command along with the -t and -p option. And there are several other options which you can invoke with, but these are the basic ones you might need in your day-to-day life. So we know that all the Zephyr contributors and users have been using Twister like in their day-to-day lives, and it becomes really necessary that nothing is breaking in Zephyr, because there are many pull requests which come in each day, and we need the Zephyr codebase to be buildable at all times and to help avoid any regressions. And it runs huge number of test cases. So all the contributors also have a very limited amount of time, and being practical, like when you submit a pull request, changes would need to be validated locally. And Twister provides many options which are very handy and can also help validate their changes in little time, and also to help avoid any failing test cases at an early stage. Therefore, I think it becomes necessary to standardize and streamline the whole testing process. And you can see the picture on the right side where Twister is just running and a developer keeps waiting for their changes to be validated locally so they can submit in a PR. So it becomes really important to standardize this process. So we talk about what is the problem exactly, but how is it like to add the test cases to Zephyr? When we are talking about adding test cases, it should have the following basic structure at the minimum. It should contain a YAML file, which could be a test case or a sample YAML. And the test cases are detected by the presence of a YAML file. And it should also contain a CMake list text file, which is a build script to add the source code to the library targets. And a prjconf, which is a configuration file for the test case or application, which we are trying to execute or add basically. And of course, the source code, which will reside under the source directory for the application or test case. And this is how the YAML structure looks like. It contains many things, but the most important things to note here are the test case identifier, the ones underlined in red. The test case identifier, which is subsys.sd.sdmmc, it starts with a section and it is followed by the subsections, which are separated by dots, and they are the complete test case names. And there are also tags which are very important in this YAML file. These tags are basically the functional domains, and these can be anything like a driver, a Bluetooth, a sensor, or any functional area. And this is very useful in CI to filter the test cases which you want to run based on the tags. So it can also be useful to anyone who is trying to run only the test cases for a specific area, like anyone who is using the product Zephyr, for example. And so, okay. So we have looked at the YAML structure and how Twister runs and its various utilities, but there are features which are not widely known, but they are still very important, but they might not be known to everybody. So I'm going to discuss about those features today. The first feature I'm going to discuss is the harness and its configuration. If a test case defines a harness, it becomes really mandatory to define a harness string to run the test successfully. And it is usually an external dependency domain, or it can be anything such as console, sensor, Bluetooth, or even a PyTest handle. It's basically something which will process the output from the Twister and use it its way. Like if you define, for example, the harness as the console, you can utilize the harness configuration to specify the regex pattern that the Twister could look at to basically say that if the test case is passing or failing. And it can be as simple as a loopback wiring or a complete hardware test setup for sensor and I/O testing. So the next feature is fixtures, which sound very familiar with like a harness, but they are different. They are a test case dependency on external device, for example, sensor, and it's an additional wiring or a special wiring specific to the test case or a complete setup. It's something which is required even before a test case runs. You cannot execute a test case if a test case has defined a fixture and you don't have the environment set up for it. You cannot do that. So, and you can only define one fixture per test case. And all the tests which need fixtures and their configuration would be skipped in default, but only if you specify the fixture option, it can activate that test case, and it can be used if the board has the environment set up. Okay, so the next one is the integration mode, which is another feature that Twister offers, and it narrows down the scope of builds and test cases. You can basically just list the number of platforms under the integration keyword in the test case definition file. Like I'll refer back to my previous slide here. And you can see the integration platforms defined under the common section. and it can contain a list of platforms, like this one specifies the native POSIX. Yeah. So, and this is especially useful to give developers a fast feedback on changes, what they introduce in a pull request, because at the very minimum, it will run on the platforms which are defined under the integration section of Twister in the YAML file. And this mode can be activated using the integration option. Sorry. Using the integration option with Twister. So, yeah. And the next up is quarantine mode, which is very useful feature that Twister provides when you're trying to run a larger test suite, and you know that a failure of one test case can affect the execution of the other test cases. That is where you can use the quarantine mode. You basically use the YAML files to define the list of tests under quarantine, and it's a sequence of dictionaries which are having the combination of scenarios and platforms. And you can also use the optional comment if you need to. And you can use the quarantine verify option to verify the list of test cases which are under quarantine. And you can also list the test cases which are defined under quarantine using the quarantine list option. And all the test cases would be skipped and marked like they will be marked as such in the reports, because quarantine is something that you go away and you don't run those test cases at all until and unless you remove them from the quarantine. And now is the very important topic for today, which is hardware testing in Zephyr, which most of you might be interested in. And like the hardware testing in Zephyr can be, activated using the device testing option with a Twister call. And it's mandatory that when you enable the device testing option, you also provide the device serial or the device serial PTY options with the Twister call, because device serial option is to provide the serial device which a board is connected to, and it should be accessible by the user. It has to be something which can be accessed by the user, and you can do that just for one platform at a time. Like you can use the device serial option and the platform option and provide the platform and just do with the single device testing. So here is the command how you can, just for reference, like how you can invoke the hardware testing with the various options that we have just discussed. But Zephyr also supports multiple device testing. Like you can test Zephyr on various connected devices at a single point of time. And this is done using the hardware map, which lets you parallelly execute some test cases. And it is, the hardware map is basically something which you generate using the generate hardware map option of Twister. And you give the user defined YAML name where the hardware map would be generated, and it would just contain all the details like the serial device, the board, the runner, and whatnot. Like it would contain all the details of the connected devices. And then like you can use the hardware map option if you already want to load the hardware map from an existing file. You can just use the hardware map option with the Twister call and provide the YAML file and point to that. And the hardware map would also be required if, for example, you want to use platforms with fixtures. Fixture is another hardware setup, so we also need the hardware map when we are trying to do such a thing, like have device testing enabled and then also providing the fixtures. Okay, so we have talked about hardware map, but how do we create them? We know that we can create them using generate hardware map option that I discussed on the previous slide. But it would contain all the details like serial device, board IDs. And when you generate a hardware map, sometimes it can happen that it contains the unknown values where you can see in the picture on the left side and that there are some unknown values for platform, product, and some of the IDs as well. But then you need to provide that, like you need to replace that with the details of the connected hardware, and that is how you can go about using the hardware map. So when you are trying to generate the map, there will be existing entries which will be updated, and the new entries would just be added. So yeah, when you have the hardware map ready, you can just point to the YAML file like it is done in the command shown on the slide. You provide the device testing, you provide the hardware map and the YAML file and the test case that you want to execute, and this will enable the multiple device testing for Zephyr. So now we have seen how we do hardware testing in Zephyr, but there can be boards which are not defined in the Zephyr tree itself, and some of you might be interested in knowing how do I execute the board which is not supported by Zephyr yet. So you can still invoke Twister with the boards which you have, but you need to provide the board root option, or the SOC root and the device tree root, which you can leverage to provide all the files that you need to provide to Twister in order to be able to make the board available as per the Zephyr specifications. So this is the command which like Twister, and you give the platform name and also the board root, the SOC root and the DTS root, and point to that. So now we know that Twister can run so many test cases, but it's important to know that it also has a reporting option, and it provides the reports to us in the Twister out directory, where you know that the JSON and the XML reports are created, and there is also a generated test plan JSON, which is a filtered list of test cases generated for every Twister run. And you can also enable various other reports, but the platform specific reports are contained under the platform specific directories, and the test case results have their own directories as well. And underneath the Twister out directory, which is the default one to capture the reports, we also have build log and the handler logs, where all the output messages of the build process are contained in the build logs, and handler logs does contain the output results of a test case. Okay. So we know that there are options which are provided by Twister, and there are various features, but there are some of the features that Twister provides, or the options that Twister provides, which most of us do not know about, but they can be very handy and a quick time saver when you are trying to validate your changes locally. Like you can parallelize the jobs using the -J option that Twister gives. And this is to basically specify the number of CPU threads which are overcommitted by a factor of 2. And this basically leverages the CPU power when some of the test cases are just building and some of the test cases are executing. So this will help to save time, and you can use that. And there is another option, only failed option, which runs only those test cases which failed the previous Twister run. So you don't need to invoke the full run. You can just, with this option, you can just execute the test cases which only failed the previous run. And the third option that I'm going to talk about is no clean, where the builds will be incremental, and you don't need to clean the direct. So when we do not use this option, usually what happens is it takes a lot of time for compilation, because underneath all the already built files need to be removed and rebuilt again. But this will save you time, since it will utilize the successfully built files, and because removing the files and rebuilding them again would just be a very slow process at the host operating system level. So, and I want to touch basically on a topic on samples and tests, which is very important for the contributors, maintainers, or anybody who is trying to add test cases to Zephyr. So we know that Twister can run both samples and test cases, but these are not exactly the same thing. These are two different things. Sample is just a working application in Zephyr, which briefly demonstrates the functionality or the subsystem of that particular subsystem, but it is not meant to be an entire test suite to be able to test out a function or the functionality. And test cases are the ones which are exactly used for testing out the features, and these are the complete set of test suite, and purpose of which is to flag twister run if anything breaks in Zephyr, and if there are any regressions, that's the job of test cases. So we know that test cases are implemented with a framework to report out the results, where you can find the results in the twister route directory. But samples are just, they just run the output through a pattern matching layer like a regex or something, and to identify if that sample failed or passed actually. And this is very important since it's important for the maintainers, because the samples and test cases cannot be confused with each other. Finally, I'm going to talk about testing the twister tool itself. With numerous features and options that are provided by Twister, and since it's scripted in Python, we also need to make sure that the tool itself gets tested, and we flag any unexpected behavior in the script if there is any, since it has gone through the development phase, but it's still there are features which are added day to day, so we need to test the tool itself. And the test cases for the Twister tool can be found under scripts test Twister directory, and the data files being in the test data directory. And you can invoke the test cases using the pytest command and giving out the path for the test cases where they reside, and you can invoke the complete set of test cases. And it also runs as part of CI. Whenever you try to introduce any changes to Twister, it will invoke a run in CI. So, and this has been a major area where I have contributed towards. So, yeah. And finally, I just want to mention a few resources that might be helpful to all of you. There is Zephyr documentation and source code, and the links of which are embedded in the presentation, which you can refer back later from the Linux Foundation's link. And also, the mailing list for the users and developers is right here, so you can use it to your advantage and post any questions if they. And you can also get connected on the Discord channel, where there are many channels for specific areas. You can always connect using those Discord channels. And I highly encourage all of you to look at the contribution guide and follow that if you're a Zephyr contributor. Any questions for me? Yeah.
I ran Twister a few times on beta, and the thing I noticed is it did take a long time.
Mm-hmm.
Is there a plan to perhaps use it almost as a pre-commit to identify the change and identify the test through test?
Yeah, it's already being done. Like in CI, if you notice, the only test cases that run are which gets which for whom you are introducing the changes in a pull request. But even before that, like if you are a developer and you are trying to submit the changes, you need to make sure your code isn't breaking anything, right? So that is where the different options like tags come into picture, and you can utilize them locally. But in CI, we already filtered them based on the tags or specific functionalities or the areas which are getting impacted, if that makes sense. Yeah.
So for the on-device testing, what needs to be done to prepare the actual firmware image to support that?
Where?
The firmware image that goes with the device when you want to do on-device testing, does that even have any special features enabled on it, or how does the interaction with the serial port work?
Oh, how does the interaction with the serial port works?
Yeah.
So,
Repeat the question for the benefit of the students.
okay, sure. So the previous question? Oh, okay, sorry. Your question is that when we use device testing, the hardware testing gets enabled, but how does the communication between Zephyr and the board works, right? So when you turn on the device testing, so Twister identifies the boards which it is connected to and identifies the various details, right? And serial device is the one where you can notice what the output is coming from the board. Is your question something else, or did I answer it incompletely?
Like, how does
Okay, so transfer the, underneath, Twister also uses like the build system, right? And for example, West, when you want to execute or build a test case, you will build it, and then you transfer the binary file or the EFI file over to the, and you flash that drive to the board, and that's how the board knows that it has gotten any binary for Zephyr, and it will try to run that. Yeah, it will flash the binary file or the executable, and yeah, it will try to run the OS and the yeah.
But you were adding code to my code. It's changing all the timing that I got carefully inside.
So that would be debugging, right? Not testing. Just run this test. I don't think there's any additional application.
Can you repeat?
I'm just concerned that you're adding code to the code that I already wrote. How is that going to affect the performance?
I didn't get your question. Can you repeat, please?
You said that you're inserting code, special code to run on the target, so that you can report back to your Python script, right?
So this is Twister. So this is testing, and this is an automated way of saying that there would be hardware testing enabled. You'll not do that for every single test case with Twister. But if I go underneath and on the low level, like if you try to just use West build command, you will just build the executable or have your binary when a specific test case or a sample is built, and then you flash on the drive to the system to the device. But when you use Twister, it's an automated way, and if you want to invoke, like for example, a large number of test cases on the device, you will need a script underneath which will take care of plugging in and power off and power on the device that you want to run the test case on. Like it will do underneath in that script. You need to provide that script with the West flash option along with the Twister call. So that's another way, yeah, if that makes sense.
I think the point is that Twister doesn't have any code. You already have samples or applications which are fast that's going to be built, and you get the same output if you use West build or use Twister. Twister is just a runner for it, which automatizes. So if you have already prepared fast, they need to have, for example, the output added in the config so they can print out, but you already have it prepared. So Twister itself doesn't have anything to the application.
So you need to serve it a script which takes care of flashing in and transferring the EFI or a binary file which was built, and then transferring it to the device. So yeah.
You don't connect to your serial and take the output.
If I don't have a serial input.
Yeah.
Twister captures the serial output from the device though.
I don't have it.
Then you won't be able to test it.
You won't be able.
You have to capture it yourself. You have to figure out some way to get the output.
And there is an option with Twister device serial PTY option, which you can use for the devices which do not have an actual physical port for recording the serial output. So device serial PTY option is something which is a user-defined script, and yeah, which thinks, where Twister thinks that the output is being outputted to the serial device, but it's actually being captured in a user-defined script, which is device serial PTY, and that is how Twister will determine if the test case was executed successfully or not, if that makes sense. Yeah. Good. Go ahead. Yeah, go ahead. I can't hear you. Can you output to the? Okay, so I'm not sure on that one, but I can get back to you on Discord. If you can post your question there, I can get back to you on that, if that is okay.
The Sager VCOM ports, it definitely works on the VCOM ports from Sager.
Oh, okay.
Yes. So you don't need a physical port.
Yeah, it works for that.
Yeah.
I believe it works for that.
We're using it that way.
All right. That's good.
Okay. Support for Renode? Yes. I believe in CI, there are test cases which runs using Renode. So that is being done in CI, like for the Twister runs. But if you try to run Twister locally, you will of course have to have the Renode set up and installed on your system to be able to invoke that. Okay. So I haven't tried actually running on my local machine, but I know this is done in CI, but I can get back to you, research more, and then get back to you on Discord channel. Just make sure to post your question there if that is okay.
So I can see the use while I'm prototyping and developing the product, but how I'm manufacturing. I want to use the same script to test the type of product where I don't have a single channel. I have a lot of logs that are generated by the software and configuration. So could you use those logs to do your analysis?
What kind of analysis? Like?
No. Okay, you're not going to be getting the async anymore because my machine doesn't have that. But Zephyr has a very excellent logging facility that I can turn on. Right, while I'm testing this device.
Okay.
And could you test hardness, process those instead of expecting the output from a serial channel?
So like you mean, so your question is exactly that, can you capture the logs if you enable the extra?
No, I will give you the logs.
Okay.
But could you somehow configure your test tool to analyze the logs? Probably not at real time, but later on. You know what I mean?
I didn't get your question exactly, but if you can elaborate, that would be great.
I know what he's talking about, and it's what he mentioned earlier with the PTY systems, that you don't need a serial output. If you can just tell Zephyr through a PTY interface how to access the
Okay.
file.
I get your question, I think. Your question is like, if you do not have an actual physical port or the serial port, then how can you capture?
Through the LTE, I can get it through the LTE modem or whatever I'm using.
Okay.
That's the way that the machine is communicating with everybody.
Okay.
The net, I don't have.
So one way to do is like the device serial PTY option as he specified. The way to go about is you specify a user defined file, and there is also a PyTest handle which is used in Zephyr, and you can also use that like and whatever test output you receive, it can be processed by the device serial PTY script, whatever you provide, the user script that you provide. If your script is capable to record that output and like, you know, it can record the output and process however it wants to. And then if you use the harness along with it, you can say that if you output to the console and you have a regex match there, then you can analyze if the test case actually passed or failed, if that makes sense. Okay. You're welcome. Anybody else?
I was going to ask how long our tabs take to run until, do you remember how long it takes to run all of our platforms or verification for vein on our Intel stuff?
Okay. So, no, I don't remember the exact time, but there are its own like hardware testing has its own problems and issues when you run a large number of test cases on the CAVS platform. But there is a CAVS Twister bash file which is available on the Zephyr tree, and you can use that to flash your boards, the CAVS board, and yeah, do testing with it on Upsquared, Whiskey Lake, or Polar Lake. Although I'm not aware of the exact time it takes. Okay, thank you. Okay, sorry. Yeah, thank you for listening in and coming for the talk today.